Hey scholars, it's Mrs. Gregerson, and I'm excited to be doing this video for you because I heard when I make this video, so the year I've made this video, there was a big freshman field trip, and so I needed to make sure my students have got all this done in advance so they can enjoy their field trip and still not get behind in math. So we're on our last unit, lesson for Unit 9, not our last unit, sorry, we still have a couple more of those. And it's about area, and it's a simple, I think it's the simplest one. I also think that we need to make sure you still have your other formulas memorized so you do really well on Friday's test. But most of all, let's review what you've learned, and then we're going to see how this all applies together. First of all, these are the formulas we expect you to have memorized for your test on Friday. So first of all, the area of a parallelogram. And remember, really huge with this, don't change capitalization on these. Go exactly the way we've written them down and the way you should have them memorized. So the area of a parallelogram we know is area equals base times height. We know the area of any triangle is 1/2 base times height, or you guys know me, I like going base times height over 2. But if you also know an equilateral triangle's formula, it's if you know the length of the side, so we let S be the side length, it's just area equals side squared √3 all over 4. But that only works for an equilateral triangle, and you have to have it memorized correctly or you won't get credit because it will just be wrong. The area of a trapezoid, we know it's the sum of the bases times the height all over 2. Again, parentheses need to be in the right location with this. I always tell people if you have fractions, it's better to write it this way. This is how some of you have always written it, and there's nothing wrong with that. So 1/2 the sum of the bases times the height. Remember, the reason why we have a formula for the area of a kite or a rhombus is because the diagonals are perpendicular, and we can use right triangles. And we have the formula area equals 1/2 diagonal 1 times diagonal 2. Obviously, you guys know me better. I like writing it as a fraction first. And then our last one that we just learned that was really hard, but I think if you learn it and using your, especially because know that I will be asking you about equilateral triangles or with regular hexagons specifically, the area formula is a apothem times the perimeter all over 2, where A equals your apothem and P equals the perimeter of the polygon. Except for I can't spell perimeter, I noticed. Here we go. Perimeter of the polygon. All right. Now, today we actually have new definitions, and on some stuff that you've had before, these would be the definitions you actually have to memorize for the test on Friday, so I'd make sure I'd get this down. So we're talking about circles. So the first thing is we got to define what a circle is. It's the first time we've really ever, I mean, we've seen them, but we haven't really talked about it. And the first is the definition of a circle. Now, first of all, the definition of a circle, make that not look like a D here, is the following: is the set of all points in a plane that are equidistant from a given point. So here's my given point. The given point we call a center, and I'm the same distance away. So I know if I'm 5 inches away, I'm going to be 5 inches away. I'm going to be 5 inches away over here. And we can just keep going on. Eventually, what type of shape do you have? If you have all the points, and eventually infinitely, if you do this an infinite number of times, you'd end up making a circle. Correct? All right, so another definition we have. The segment from the center to, let's just say center of the circle, not to the circle, of the circle to any point on the circle is the radius. Okay? Now, how many radii does a circle have? A circle has infinite number of radii, but it only has one radius length because they're all going to be the same. So I can draw an infinite number as I want, and we all know every single time the radii of a circle are congruent. So we can use that all the time with it. Also, we call a circle by its center point, and so we call it center C. So like circle C here. So if right here, this would literally be your notation. Isn't that cool? Circle C. So it looks like almost like a donut, like a circle. You put the center point in it. That way you don't think of it's an O or something, or a 0 or something like that. And that'd be called circle C. Pretty easy to do. Also, just some common sense things. If we talk about what's called the interior of the circle, and we talk about the exterior of the circle. The interior is everything on the inside of it, and the exterior is everything on the outside. Now here's the difference. What's the actual circle? Those set of points. So it's not a solid shape. It's not shaded all the way through. It's just the set of points around that given point in a plane, which makes it a circle. So kind of cool with that. Congruent circles, I think this makes sense because we can have circles that are the same shape and size, right? Are circles with congruent radii. One last definition that on this page that we have, and I think it's something you need to know, and you guys see quite a bit, it's called concentric circles. They're circles that lie in the same plane and have the same center. Now, obviously, one of the most common ones you've ever seen is something like a target, right? You go around and around and around. Or another example of that is the target trademark, right? Is easy to recognize. So concentric circles are a big deal. Like that's how you get tires. That's, you know, how you put something within something within something pretty easily. And we're going to use that later when we're talking about area. All right, some other things that are common sense that I expect you to know before. What a diameter of a circle is. Okay, the diameter of a circle is the line segment whose endpoints are on the circle but passes through the center. So notice the endpoints are on there. How many different diameters can you have for a circle? You're going to have an infinite number of diameters, but they're all going to be the same length. Also remember that a diameter, the length of the diameter, which we're going to let d be the diameter, right, is twice the radius. So it's 2 radii will add up to make 1 diameter. All right, then we have another definition that many of you know is if you could take a circle, take it apart at one point and then just lay it flat, that it turns into a line segment, and that line segment has a length called the circumference, and the circumference is just the linear distance around the circle. And then you guys were given formulas for it. When you had this, we called it pi times diameter, or diameter times pi. Another one that you do if you don't want to work with the diameter is you go 2 pi times the radius, because diameter equals 2 times radius. So you need to memorize either one or both of those formulas in order to do the circumference of a circle. Okay, now I just went through a lot of the basic definitions for circles, so if you're not sure about it, come talk to me. I'm sure most of you have done enough with circles before. This is like Gregerson, this is old hat. But here's some things about circles. We're going to do the circumference and area of circles. Here's the thing. You have to do circumference and area of circles exactly the same way we've done area, where you write down your formula first. And all right, I need you guys to hear me on this. Half of you are probably not even watching this video and you're going to get stuff wrong on your homework, but hopefully the other half of you who are paying attention to this, write formula down first, work directly below, final answer. Work directly below, and then your answer is still going to be labeled too. Answer and label. All right, so let's do this together. It says find the circumference of each circle. Leave your answer in terms of pi. All right, so here's why. Remember pi, for the longest time, you guys approximate as 3.141. You know, here's what I need for you guys to do. If I ask you to give me a decimal answer, I need you to do it using the pi key on your calculator because it will use a lot more decimal places and be more exact. But when I ask you to leave something in terms of pi, that means I want the exact answer that you can give me without having to use basically your calculator. So let me give you an example of what that means by terms of pi. All right, I'm given the diameter, so it makes more sense for me if I'm given the diameter to use the first formula. So I'm going to go circumference is pi times diameter. So I put pi here, I put 30. Now most of us don't put the 30 at the end of a problem, right? When we multiply them together, we go, that's 30 pi, and that would be in centimeters because this is a linear length. All right, that's exactly how I want you to show your work on this. Now the next one is that you used radius. Well, obviously that makes sense to use this formula, right? So with it, you're just going to sit there and go, circumference is 2 pi times the radius. So I get 2 pi times 6. Well, you're multiplying together, so it doesn't matter what order you do. So I go 2 times 6, which is 12, and then pi comes along, and that would be centimeters. What do you guys think? Easy? Yeah, me too. All right, the last one's in diameter. So we know that we're solving for the area of it using diameter. So we can go circumference is pi times diameter. So I get pi times 5 over 2. Now, that's the same thing as putting pi over 1. Remember, we don't have to freak out about fractions. A lot of times we can just put something over 1. It turns it into a fraction. You multiply your numerators together to get 5 pi and your denominators to get 2. And that would be in meters. Guys, isn't that like the easiest thing ever? I know. All right, so now let's go back to basically from 3rd grade on, that you had an area formula for this. What is the area of a circle? And I think every one of you would go pi times radius squared. And remember, your radius, you can also remember the diameter is twice your radius. So if you ever need to find your radius, you can take your diameter and divide it by 2, right? So those are simple things that you can use. So we can use our diameter right here if we needed to. But just make sure you have the area formula memorized. All right, now we're just going to do lots of problems with this. And guys, this isn't hard, but you just need to make sure that you're looking for the radius. That's the one piece of information you always need. So on the first one, it says, find the area of the circle, leave your answer in terms of pi. So again, I'm not asking you to use your calculator. If it says to use your calculator, remember to use the pi key. On this first one, it says the diameter is 11 centimeters. Well, if the diameter is 11 centimeters and I need the radius, I'm going to just take 11 and divide it by 2. Because remember, the diameter is twice the radius. Then I write my formula down. Area equals pi times radius squared. Guys, let me put it this way. If you want to make sure you get it right, use parentheses when you're doing this. Because if not, you're going to get it wrong, and you're not going to end up squaring everything you need to. Because when I put that in parentheses, I see 11 over 2, that quantity being squared. That means the 11 will be squared, and the 2 is going to be squared. So I end up getting 11 squared is 121. So we go times pi, because again, I'm going to put that over 1, so I can put it in the numerator. And then 2 squared is 4. So that's 121 pi over 4, and then we label it square centimeters. The radius equals 7 inches. Well, that one's easy. Area equals pi times radius squared. Again, notice I'm just getting in the habit of using the parentheses every single time. And that turns into 49, because 7 squared is 49. Pi square inches. That's it. Don't overly complicate this stuff. Circles are easy until you see a problem like this next one. All right, so I look at C, and I'm still supposed to solve for the area of the circle. However, I have what's called an inscribed right triangle. Looking at this right triangle, do you guys see anything special about it? Yeah, it's a 6, 8, 10. Well, the 10 is the diameter. Well, what do we know that the diameter does to it? It's going to bisect it. So that's going to end up being my radius equals 5. Now, if you forgot that, could you use the Pythagorean Theorem to get the length of the diameter? And the answer is, of course you could. So you get your 36 plus 64 equals diameter squared. Oh, look, 100. Because we're good math students, remember our plus or minus. But we know we can drop the negative because it's a positive length. So diameter was 10. So the radius is 5, right? Because radius is half the diameter. So then we go pi times radius squared. So I get pi times 5 squared. That's going to be 25 pi. And then it gives us units, so we got to go square units this time. All right, this, as you can see, this stuff isn't hard. You just have to make sure you do careful keeping it in terms of pi. Just make sure, again, I always say if you plug it in for either the diameter or the radius, guys, if there's circumference or area, I would always use parentheses so you don't lose track of yourself. Okay, now this is where things get a little more complicated, but I like this because it really applies a little bit more what we've been learning. This kind of brings a combination of stuff in. These are called shaded area problems. Now, one of my problems I put on here, I realized wasn't a good one, so I'm going to change the directions just for that problem, but the rest of them I think will be pretty good. Now, here would be a typical problem for part A. Oh, by the way, it says leave your answer in terms of pi and simplest radical form. So you might actually have radicals in this that you have to worry about too. But in this one, you can tell that you have a square or quadrilateral that circumscribes a circle, or we say the circle is inscribed, it's on the inside. So I want to find the shaded area, so you can see the black. Well, wouldn't it be nice if I could remove the circle from the square? That's exactly the thought process you have to use. I'd like to remove it. Well, that means I need to remove the area of the circle from the area of the square. Well, we know the area of any parallelogram or square is base times height, but what is your base, because this would be here and your height would be here, is it? Well, we use the idea that we know about a circle. If I drew in the diameter of the circle vertically or horizontally, should I be able to find the diameter or the base and the height of the square? Yeah, because we know all those radii are the same. So if that's the case, we know the base would be 12 and the height would be 12. So I got 12 times 12. I get that to be 144 square units. Now remember, I need to know the area of the circle so I can remove it, okay? So with that, the area of the circle, I got pi times my radius. Well, this time is 6 squared, so I get 36 pi. So what is the area that's shaded? Well, that's the square minus the circle, and that means square units. So a lot of times when you have a shaded area problem, I said lots of times, not always, you have to take the time to subtract. Okay, now this is the one I have to change. So I didn't have everything right here. So find the non-shaded ring. So basically I'm asking to solve for the area of this part of it. Here's the other thing I didn't tell you, which wasn't very good. What's the radius for this whole thing? Let's call that radius to be 4. Okay, so with that, make sure I make a little more sense. Don't I really need to do it like a donut? But I need to take the big circle, because these are concentric circles, right? The big circle, and subtract the smaller blue circle from it in order to get this whole ring thing. Okay, so let's try it real quick. So the area of, and I'm going to call it like this, area of big circle, we know is pi times radius squared. Well, that's going to be my radius of 4, so I get pi times 4 squared. That's 16 pi. Then I'm going to get the area of the small circle. Pi times radius squared. Now what's going to be the radius of the small one? Well, if you notice, these are marked congruent. So that means it would have to be 2. So pi times 2 squared. That's going to give us 4 pi. So what's the area of, I'm going to call it the ring, the non-shaded ring. Well, that's going to be 16 pi minus 4 pi, which gives us 12 pi square units. Notice how I treat the pi like a variable. In your brain, think of it that way. It's just a variable that you have to have. And so this would be our final answer. Okay, so the next one could seem a little bit complicated with this one, but I like this quite a bit. First of all, I'm looking at this and I'm looking at the shaded area, so it's the gray area here on the circle. And what I would like to remove is to remove a triangle. Well, guys, what type of triangle is that? That's right, that is a 45, 45, 90. So what do we know about it? So we know the legs are going to be the same. And then we know we should be able to calculate the diameter, right? Or the hypotenuse. Well, the legs are both 6. What's going to be the length of the diameter? Well, that's 6 root 2. So how are we going to calculate this? Well, I need to do the area of the circle first. Because remember, I need to take the bigger one and subtract away the white, so the triangle. So when I'm doing that, we're going to go area of the circle. So that's going to be area equals pi times radius squared. What's my radius going to be if the whole thing is 6 root 2? Well, we know it will be bisected, and so we know it would be 3 root 2. So my radius is 3 root 2 squared. You know, I don't even like how that's seen. I'm going to see if I can find something better here to write that. So this would be 3 root 2, and this one would be 3 root 2, because some of the parts equal the whole, right? Because we know the whole thing is 6 root 2. All right, so we go back to here. Oops, I don't think I got my brown anymore. Oh, there we go. All right, but now the reason why I'm using parentheses is I need to remember to square the 3 and square the square root of 2. So I get pi times, well, what's 3 squared? 9. Square root of 2 squared is 2, and that gives you 18 pi. All right, so we know the area of the circle. So this is the circle's area. area of a circle. Now I need to find the area of the triangle. Well, the cool thing about the area of an isosceles right triangles, I can just use the legs, because remember the area of right triangles, we can use the legs to be the base and the height. Well, they're both 6. So I got base times height over 2. So I got 6 times 6 over 2, and that gives me 18. So the area that's shaded is going to be the circle, 18 pi, minus the area of the triangle, which is 18. Now guys, some of you are like, oh, let's combine these. You can't, because remember the pi is like a variable, so it makes them unlike terms with each other. Correct? Oh, look at how that's circled. All right, so far, so good. You can see the multiple steps. Notice normally if you're doing something with a shaded problem or you're looking to take a portion of it, you're doing a subtraction type problem that you're working with. So here is the last one. This one where it could seem so hard and so complicated, but keep it simple. When you look at it, you ask yourself, what shapes do I see? And do a lot of you see the big parallelogram or the big rectangle, right? We see it right here. And do we have a formula for that rectangle? Yeah, we know that the area of the rectangle is going to be, let's use purple here. Area of the rectangle is going to be base times height, which we know is going to be the base, I'd let that be 12 meters, right? 12 times the height of 2 meters. So that's 24 square meters. However, I want to get rid of, I only want the shaded area, so that means I want to get rid of 3 semicircles. Now, the cool part about this is, even though I've never taught you the area of a semicircle, how would I get it? Well, it's 1/2 the area of a regular circle, right? So couldn't I just write that as pi r squared over 2? So yeah, so I get pi, my radius. Well, what is going to be my radius for this thing? Well, if this whole thing is 12, do you guys agree with me that every single one of these from here to here would be 4? And isn't it make sense with the side here? The radius is 2 for each one. I mean, there's nothing that's contradicting this as we go through. So my radius is going to be 2. So I'm finding the area of one semicircle right now. So I get 2 squared all over 2. So guys, look at this. That's 4 pi over 2. That's 2 pi. However, I have more than one semicircle. I have how many? 3. So when I'm finding that shaded area, so the area that's shaded, can I take my rectangle minus 3 semicircles? So 3 times 2 pi. So I get 24 minus 6 pi square meters. Not hard. You just got to kind of think through the parts, right? All right, excellent, guys. I am very proud of you for sticking out this unit. It's hard, and I know regular polygons are really hard, especially if you haven't been working with them before. So we're going to do a lot of practice with those on block day before, when we're reviewing for your test. I would also suggest starting the guided test review. This is going to be more, the hope on this test review is to help you guys get started on learning how to study better. Like, one thing we just want to develop in you is better study skills for a math course. So it's very guided. It says, all right, do this first. Okay, do this next. And then the big thing that we do is we hardly give you any practice problems. You actually have to go into your notes and homework and actually find your own practice problems. So if you need help in that, that's what I would do. All right, guys, have a great day, and I hope their field trip went well. And sophomores, I hope you stay out of trouble.